Hello, as part of the module Computer Science Research Methodology, I will present to you today a paper about privacy and security with the title A Non-cooperative Location Privacy, a Game-theoretic Analysis. I will start by providing a quick overview on the context of the paper and provide some information on the journal the article was published in and the authors. Then, I will summarize the main ideas of the paper and describe the methodology that was used. Finally, how the paper position itself will be discussed. The research paper was not published at a conference but in a journal called Transactions on Dependable and Secure Computing, which publishes research results about systems and networks that are dependable and secure to a certain level and take into account performance. Topics include, but are not limited to, design for dependability and security, evaluation, application-specific areas, software design, and new technologies. The publisher is IEEE, which is the Institute of Electrical and Electronics Engineers. It is a professional association for electrical and electronic engineering, telecommunications, computer engineering, and allied disciplines. To evaluate the journal, I use different metrics that we have seen in class. The journal has an impact factor of 6.404, meaning that on average, every year there are 6.4 citations of articles published in the journal. In total, it has published 81 articles and was cited over 2,400 times. The journal has 47 articles that were published between 2014 and 2018 that have at least 47 citations each, which corresponds to the H5 index. Our journal ranks 9th on the Google Scholar ranking of journals about computer security and cryptography and is in the category A, so in the best 24% of the core ranking. The authors of our article are Mohamed Hossein Manchey and Jean-Pierre Hubeau. Mr. Hossein Manchey has been cited in total over 2,700 times and has published at least 20 articles that have been cited 20 times. And he has written at least 33 articles that have been cited by at least 10 sources corresponding to the I-10 index. Mr. Hubeau has in total 39,505 citations, an H index of 85 and an I-10 index of 261. The article is the third most cited article of Mr. Manchey and 47th for Mr. Hubeau. Mr. Manchey has his own webpage and is part of the Isfahan University of Technology, which has a ranking of 748 of 2,000 universities, whereas Mr. Hubeau is part of the EPFL, which has a ranking of 79 among 2,000 universities. Now, let me quickly summarize the work. The general context of the article is about mobile and ad hoc networks, which are decentralized type of wireless networks. The network is ad hoc because it does not only rely on pre-existing infrastructures such as routers in wired networks or access points in managed wireless networks. Instead, each node participates in routing by forwarding data for other nodes, so the determination of which nodes forwards data is made dynamically on the basis of network connectivity and the routing algorithm in use. All this means that nodes need in some sort to get organized themselves and communicate with each other without relying on other infrastructure. The mobile and infrastructureless nature of networks brings with them new security challenges. Hence, we need authentication for most security protocols. What is the problem solved by this paper? Well, the problem consists of the possibility to monitor the pseudonym used for authentication and hence to track the location of mobile nodes. So, there is a need for protecting location privacy of mobile nodes, which corresponds to avoiding that other parties are informed about a node's location. The solution that is often suggested to protect location privacy is that mobile nodes collectively change their pseudonyms in specific zones. But the challenges are that it is costly to change the pseudonym for several reasons. For example, it can cause overhead, nodes can have limited number of pseudonyms so they can become a scarce resource. Also, not all zones provide high location privacy guarantees. For all these reasons, some mobile nodes might decide not to change their pseudonym. In fact, at least 2 mobile nodes need to change their pseudonym for privacy to be guaranteed. If only one changes, there is no privacy protection. All will know that only this node changed and will be able to identify it. So, non-cooperative behavior of mobile nodes is plausible because it can be costly and can result in no location privacy protection for other nodes. The idea of the paper is to use game theory to understand how mobile nodes behave if they are self-interested and taking into account that each node has the objective to maximize location privacy and to minimize the cost of this. Each node has 2 possibilities, to cooperate or not. The main results by the authors are actually counterintuitive. There are 2 scenarios. One's using complete and then incomplete information. The findings are that even with incomplete information of the player, it is possible to find an equilibrium with high location privacy, minimizing the number of used pseudonyms. This means that when the cost of changing pseudonyms becomes small, the nodes act more selfish, and nodes become more cooperative when the cost of changing pseudonyms is higher. This can be explained by the fact that when the cost of pseudonym is large, the selfish nodes care more about a successful game, which is here location privacy, and hence an improved achievable location privacy. Let's dive into the methodology adopted in this paper. A quantitative method was used to evaluate the author's contribution. For that, they first created a model, developed a theory, and then used simulations to prove or refute their initial statements by comparing simulation results and theory. The model created is used to represent the whole system, which includes mainly networking and game theory. Networking knowledge was translated into different formulas representing the uncertainty that nodes encounter with regards to other nodes when trying to achieve location privacy. A location privacy loss function was also defined representing the user-centric model of location privacy. In fact, each user can decide when and where to protect its privacy. Another formula was established to represent the user-centric location privacy of a node. With regards to the game model, there is a set of players who have different possibilities to cooperate or defect, meaning to change or not their pseudonyms. A payoff function is taken into account. The decision of a player will depend on the payoff function of his opponent. Equilibrium concepts are formulated, where each player will always maximize his gains. Definitions about response of a player, definition of Nash equilibrium, and definition of Bayesian-Nash equilibrium are also set. Theories are expressed in theorems and lemmas. Theorems are what will be proven during demonstrations later. They cover theories about the different type of equilibriums, which can be Nash equilibrium, Bayesian-Nash equilibrium, threshold equilibriums, etc., for the different scenarios, which are complete or incomplete information, 2 or n-player games. Lemmas, which can be seen as additional or helping theorems, are also about equilibriums in the different scenarios. All theory is packed into mathematical formulas. In the annexes, the authors provide mathematical proof of their theorems and lemmas, which will then be used for simulations. This paper uses simulations which are approximate imitations of systems over a defined period of time. For that, we first need to create a model which represents characteristics, behaviors, and functions of the system to be simulated. The model corresponds to the system itself, and the simulation corresponds to the operation of the system. In the paper, MATLAB was used to solve the equations defined earlier. The tool makes changes to the variables and performs predictions about the behavior of the system. The results of the simulations in MATLAB are averaged over 1,000 simulations for the two-player incomplete information game. So there was no experimentation on a real system, but simulations of the system. Simulations are generally used when the real system cannot be engaged. This can be for the following reasons. The system is not accessible, it is dangerous or unacceptable to engage it, it is not built yet, or it may simply not exist. I think simulations were used here because it would have been costly and complicated to carry out experimentations of this kind. Once the results of the simulation have been obtained, they are analyzed and their performance is compared. In fact, it is the Bayesian-Nash equilibrium performance which is compared with the random strategy and with the social optimal strategy, which is that all nodes will cooperate. What is observed is the welfare achieved, how much the system performance is degraded compared to the other strategies, and how many pseudonyms are changed. Based on these findings, the authors were able to take conclusions. Now, what can be potential problems of their methodology? Key issues when using simulations can be to obtain valid sources of information about the relevant selection of key characteristics and behaviors, also to use simplifying approximations and assumptions within the simulation, and fidelity and validity of the simulation outcomes. And finally, procedures and protocols for model verification and validation of the outcome. So one could ask oneself if there have been too many simplifications, if some assumptions are wrong, if the model does not represent reality well. For myself, it's hard to judge as I'm not an expert in this field of network privacy and security. Moving to the last point of this presentation, let's consider the positioning of this paper compared to other papers. Related work explains why multiple pseudonym technique for achieving location privacy makes sense. It has been shown that the adversary can identify mobile nodes thanks to their location. So changing pseudonym is not a measure that will guarantee location privacy. This is shown in the article of Beresford and Stajano of 2003 and Ho and colleagues' paper of 2006, among others. Other works, such as Ho and Gruterser's article of 2005, show that even without pseudonym location privacy, it is not guaranteed. So location traces should be altered spatially. Related work also explains when to change pseudonyms. For example, Gruterser and Grunwald 2005 paper suggest to change MAC addresses every time a pseudonym is changed or obscure the MAC address. Other research articles describe the possibility to identify devices according to their characteristics at different layers. For example, at the physical layer, where wireless transceiver can identify wireless devices using different techniques, as explained by different papers. At the link layer, Franklin and colleagues describe that it is possible to distinguish between devices and driver. At the application layer, identification of devices based on clock skews are explained as developed in the paper of Kono and colleagues of 2005. These papers show that higher layer privacy mechanisms are useful, for example, mixed zones. Other papers state the techniques different than the multiple pseudonym technique for location privacy. These techniques are, for example, group signatures, as shown by Schaum and Van Hees in 1991 article, ring signatures, as explained in the Rivest, Shamir and Trauman paper of 2001, and anonymous credential systems, as explained by Kamenisch and Van Herrewegen article of 2002. Also, different drawbacks of these techniques are named. Finally, related work uses game theory to evaluate strategic behavior of mobile nodes and ad hoc networks for node revocation, such as stated in 2008 by Raya et al., To understand why decentralized anonymity infrastructures are not widely used today, as stated in the paper of Acquisti of 2003, and to show the role of privacy in economic transactions, as stated by Varian in 1996. This paper is different in the sense that it explains that location privacy is achieved by changing pseudonyms in specific zones called mix zones. Also, a new aspect of privacy is studied, which is how privacy can be achieved among non-cooperative nodes. I hope you liked my presentation. I thank you for your attention and please don't hesitate to contact me should you have any question.